Section 2.4 is where we are going to introduce different types of rigid motions. A transformation is a function that takes points in the plane as inputs and gives other points as outputs. In a transformation, there is a pre-image that is mapped onto the image. A rigid motion, also called a congruence transformation or an isometry, is a transformation that preserves distance and angle measurements. So all that's saying is that when you are doing a transformation, the shape should not be changing. Okay? So there are three different types of transformations. A reflection, which you are just flipping across. A translation, where you are shifting or sliding it across. And then a rotation, where you're going to actually turn this guy around. So the first thing we're going to do is just make sure we know what those transformations are. So in example number 1, it says identify the type of rigid motion shown in the photo as a reflection, translation, or rotation. The landscape is mirrored onto the water. This is an example of a reflection because it is just flipping over and giving the same picture backwards. Pause the video and try the check question. In the check question, the game of checkers where players are moving their pieces in a diagonal is an example of a translation because you are just taking this guy and sliding it across. In example number 2, we're going to do the same thing, identify what transformation we are, but in a coordinate plane. So on letter A, they have this original picture and they took this guy and they were sliding across there. So letter A would be a translation. Letter B, they took this crescent and they were flipping it across to that other side. So this would be an example of a reflection. On letter C, they have this bold triangle, and I see the top of it has turned to go to the top. So therefore, they have rotated that picture. Pause the video and try the check question. In the check question, they have rotated the bold picture so that this top is now no longer at the bottom. It is kind of pointing towards the top. So that would be you turning it, which is a rotation. Example number 3 is where we're going to practice doing a reflection. We are just going to practice reflecting across the axes. So the first thing I did was I took these points and made sure they were plotted over here in your picture. What you want to do is you're going to find whatever the axis is that you are reflecting across. So this is the x-axis, and if you forget, it is labeled in your picture. You are going to count the distance to that axis. So I'm going to count to it. So 1, 2. That means to reflect across there, I would have to be 2 away. So 1, 2. So down here is where my A prime would be. So anytime that you do an image, you're going to label that with an apostrophe and name it a prime. So I'm going to do the same thing with B, but now I have to move up to go to my line. So I'm moving 1, 2 to get there. Now I got to move 1, 2 to go away. So this would be B prime. For C, I would do 1, 2, 3, 1, 2, 3, 4, 5 to get to that x-axis. Then I go away. 1, 2, 3, 4, 5. So my C prime would be here. So reflecting across, it would look like this. So A flipped down, B flipped up, C flipped up. Then I just wrote down the coordinates of that point. So I had 2, 2 for B prime. A prime, I had 1, 2, 3, and then negative 2. For C prime from the origin, I had 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's why I wrote those coordinates. Pause the video and try letter B. So on letter B, you have to reflect that same triangle across the y-axis. So now I am using the y-axis, so that would be this line, and I'm taking these points across there. So I'm going 1, 2 to get there, and 1, 2 to go away. So here would be B prime. Same with A. 1, 2, 3 to get there. 1, 2, 3 to go away. And then last, C. 1, 2, 3, 4 to get there. 1, 2, 3, 4 to go away. Now I'm just going to find the coordinates of those points. So A prime from the origin, -3, +2. B prime, -2, -2. And C prime, -4, -5. All right, so there is homework after this section, which you will need to complete, but there is another part to section 2.4. So flip on over to the second part. Okay, so on the second part, what we're going to do is practice doing translations and rotations. So remember, a translation is where you're going to slide your figure. So here they give you a quadrilateral with these vertices. So I went ahead and plotted those points down here in my graph. So -8, -2, left 8, down 2, -9, -5. This is going by 2, so -9 is in the middle. -5 is also in the middle of 4 and 6. -4, -7 for S, and then T is -4, -2. It's wanting me to translate with this vector. Translations are probably the easiest. All you have to do is add these numbers to your X and your Y coordinates. So that means that I'm going to add 7 to my X here, and I'm going to get -1. And I'm going to add +1 to -2, and I'm going to get -1. Then I'm going to keep going. So I'm going to add +7, get -2, add -1, add +1, get -4. And then I just keep going. So add 7, add 1, add 7, add 1. So if I were to plot these points over here, so -1, -1, that's not right. Right here, -1, -1, -2, -4, 3, -6, and then 3, -1. This would be your same quadrilateral, but shifted. So notice that nothing changed. So I should still have this on the left side. This should be on the right, and then top and bottom should still have the same picture. So a translation just shifts it or slides it one way. Pause the video and try the check question. So in the check question, doing the same thing, take all of these coordinates and just add your X translation and your Y translation. So -3 plus 5 will give you 2. -3 plus 1 will give you -2. Keep going. So add 5, add -3, I get 0, 0. C prime is going to be 3 and 2. And then D prime, you're going to get 4 and 0. So again, just adding this guy to the X, adding this guy to the Y. So add the X's, add the Y's. Okay, then the other part we're going to talk about are rotations, and there's going to be 4 different rotations we talk about. We're going to rotate counterclockwise, and we're going to rotate 90 degrees, 180 degrees, and 270. So the first thing I want you to know is just realize which direction we're going. So clockwise is this way, counterclockwise is the other way. So think of a clock, right? So I'm going the clockwise, we go this way, counterclockwise, I go the other way. The other thing I want you to know is, so when you have a circle, right, and I start here, if I rotate counterclockwise, every quarter is 90 degrees. So if I rotate a quarter of this, this would be 90 degrees. If I rotate 2 quarters or a half, that's going to be 180. If I rotate 3 quarters, I'm at 270. And if I go all the way back, I'm back at the beginning, which is 360. So remember that we're going to be going in quarters of a circle when we're talking about 90, 180, 270. Okay, so down here where we're doing rotations, you're going to want to use these formulas up here to help you figure out your coordinates. So in example number 5, it says that you've got a parallelogram with those vertices. It wants you to find the coordinates of the new ones, and we are rotating 180 degrees. So this formula here says take these coordinates and we're going to do the opposite of each of them. That's what this negative is telling you to do. So for f prime, I'm going to do the opposite of 2, which is -2. And I'm going to do the opposite of 1, which is -1. Same here for g. I'm going to do the opposite of 7, opposite of +1. Opposite of 6, opposite of -3 would be +3. Opposite of 1, and then opposite of -3. So 180 degrees is really easy. It's the other two that's a little harder. See if you can figure out the check question with 270 degrees. So 270 degrees, this is your formula that you want to use. So it's saying that you're going to do y and then x. So remember, your original form was x then y. So what this is telling you is that it wants you to flip these two guys around, and then you're going to do the opposite of that x coordinate that you put here. Okay, so I'm going to flip these two around, so that means it's going to become 2, 1, and then your x coordinate that you put here is going to be negative, so that's why it's 2, -1. So then I'll do the same thing here. Flip 3, 4. X coordinate's going to become opposite, so that's why it's 3, -4. Flip, so 1, 6. That guy becomes opposite. Flip, so 1, 3. This becomes negative. So the same thing happens with 90 degrees. This notation is telling you to flip them around, but the change is that you're going to do the opposite of the y coordinate that you put in that first position. Okay, so 180, super easy. These two always stump students because they don't understand the notation. So flip it around, change the sign on wherever that -1 is. All right, that takes care of transformation.